Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss the topic about discrete probability distribution. This topic, while discussing, we are going to cover about random variables, definition of probability mass function, and probability distribution in that discrete probability distribution. These are the three subtopics which is included in the main topic, discrete probability distribution. What is discrete probability distribution? This discrete probability distribution, in another way we can call it as probability mass function. Suppose x is a discrete random variable. This random variable, which is denoted by always the capital letter, that is the reason here x is written in capital. That is uppercase form it should be written. If in case that capital X is a discrete random variable with possible outcomes, that is they are x1, x2, so on, xn, then the probability of p of x1, p of x2, so on, p of xn. That's what in a simple notation it is written, p of x equal to xi. It's nothing but this I, it's taking the values from 1 to n. The reason is here x1, x2 up to xn it is written. So I is taking the value from 1 to n. We can see it here. So I is taking the value from 1 to n. So the probability of x equal to xi, it's nothing but p of xi. And if the numbers p of xi, if it is taking I equal to 1 to n, then it should satisfy two conditions. These two conditions, what we are going to see now. If these two conditions are satisfied, then we will call it as discrete probability distribution. What are the two conditions? The first condition is p of xi is greater than or equal to 0. That is probability of xi. That is, I will take the value. We already discussed, that is, I is going to take the value from 1 to n. So probability of x1, probability of x2 up to probability of xn, it is 0. The value is 0, otherwise greater than 0. Greater than 0 means it is mathematically greater than 0. The meaning, what it indicates, the mathematical, the notation is the probability of x1, x2 up to xn, it's nothing but positive. So the greater than 0, it's nothing but positive. The value is positive. Next, the second condition is total probability. If you add all the probability, the values, add, that is the thing, the mathematical notation here, summation is there. SUM, summation is there. These two conditions are satisfied. That is, probability, it's compulsory, it should be positive. The sum of the total probability is 1. If these two conditions are satisfied, then we will call it as discrete probability distribution. Otherwise, probability mass function we can call. So we can notice here this is the sample space. we are having one coin in our hand. That coin we are tossing. If we toss the coin, one coin, so the total output, if we toss one coin, we will be getting head or tail. That we know it very, very well. So this one event we are keeping, that is some condition. That is the condition what we are keeping. We want the number of head getting is our event. So it's a R denotes that is a real number. Now if I toss this one coin, so in my hand one coin is there, that one coin I tossed it, I'll be getting either head or tail. Among these two possibilities only one will be coming. My target is I want it head. That is number of head. Number of head. Head is my target. So if head comes, I am success. That is probability of success. If I am not getting head, that is probability of failure. Yeah, we can see it. 0 and 1. So now head and tail is there. The outcome means HT we will tell. A simple example I can tell. So now the students, we are writing the exam. The answers are, the question paper will be given. Answers we will fill up in the answer sheets. After finishing the result will be exam over. After a few months, the result will be declared. After declaring the result, if anybody question us, what you got, what is your result of your exam, we won't tell I wrote a 5th question correct, I wrote a 3rd question correct. Boldly we will tell I got 90 marks, I got 98 marks. So we wrote the answers, but the result we are telling in 98, 90. They are nothing but marks, we know it, but the marks, they are nothing but real numbers. The same concept only here also. We tossed one coin. The one coin tossing output we know it, head and tail. We want a head. So we got it success. That is converted into real number 1. I am tossing the coin. Head I wanted, but I am getting a tail. I am getting tail. I am getting. That means tail means there no head. The no head mathematically how to be denoted? It's nothing but 0. So this throughout this module, this concept, no, it is denoted by mathematically 0. That we have to keep it in our mind. So no head, it's connected to here 0. That we can see it. So we can see it here. So no head. It's a one head we got it. So we can see here. Now probability of xi. Now this real number 0 we are naming as x1. 1 is named as x2. Now this x1, it's nothing but we are going to find probability of xi. The probability of xi, the basic definition of probability, that is, what is our given question, number of head we have taken. So the total outcome is 2, that is sample space is 2. And satisfying our condition, the head is connected how many times? 1 time. So this is the basic definition of probability, that number of favoring event. So what is the given condition, that favoring how many times? 1 time divided by total sample points which covered in the sample space. It's nothing but 2. So 1 by 2, it's nothing but 0.5. So the probability of x1, that is the probability at the point x equal to 0, we got it 0.5. Next, this 1 actually we named it as x2. Now the probability of x2, it's nothing but that is also 0.5. So now this everything, this capital X random variable, that is X from S to R. The random variable, what is the condition, the number of it which is applied on the sample space, the output is coming in real numbers. Here the real numbers we have done, we got it the probability using the definition of the definition of probability. So I can see it now. So it is given 1 coin. So the sample space is there. Outcome is head and tail. And this is X is nothing but the random variable. The outcome H, it's a 1 time. 1 it is connected because we are getting 1 head. Tail is connected to 0 because there is no head. Next, probability of Xi. The 0 we assumed we have taken X1. 1 it is taken as X2, then probability of 0, that is probability of X1, it's nothing but 0.5. Next, X2, that is probability of 1 or probability of X2 is 0.5, satisfying the basic definition of probability. Now we can see it. The probability distribution table, how it is framed. So now X equal to Xi. First here X1, X2. Here it is there. Here the example we have taken only 1 coin. For the 1 coin, the output is the maximum. The total output is head and tail. Suppose if it's 2 coins, here it will be increasing the output. Naturally, here the real number also will increasing. If it is 3 coins, more it will increase. So in the table, we will write it x3, so on up to xn. Next, probability of x equal to xi. The meaning is we are going to find probability of this x1, it's nothing but p1. Next, this we are going to find probability of x2, it's nothing but p2. Similarly, p3, so on, pn. It's nothing but this is it's a probability distribution table. Now, we are going to solve a problem using discrete probability distribution. In this table, it is given in the question. Using this table, we are asked to find the value of k, mean, variance, and the fourth point, we are saying when probability of x is less than 6, greater than or equal to 6, it lies between 0 and 5, and it lies between 0 and 4. One more question, x is less than or equal to k, which is greater than 1 by 2, that is 0.5. What is the value, maximum value of k? Using this table, we have to find all these 5 questions we are going to solve. So the first question is to find the value of k. Very simple thing to find the value of k. Any constant value, we can use this formula. The total probability distribution is 1. That we are taking. That is, this is the formula. Summation I equal to 1 to n, pi equal to 1. That is, from 1 to n, the total probability, if we add, the value is 1. And what about this? This is nothing but according to our problem. According to our problem, it starts from 0 to 7. It starts from 0 to 7. So, we put it 0 to 7. Pi equal to 1. Now we are going to apply I is going to take the value from 0 to 7. So we put it here P0, P1, P2, P3 up to P7 because the table is up to P7 which is equal to 1. The reason for this 1 is the total probability distribution is 1. We are going to substitute the value. This question, the table which is given in the question, looking at that, we will pick the values from there. We want it P0. This is if it is X0, this is P of X0. That means this is P0. That is P0. So P0, where it is here. Next P1. P1 is K, so we can see the connectivity is here. Next P2 equal to 2K, the connectivity is, this is 2K because this is X2. Next P3 equal to 2K and this is 2K. The last one we can see it, P7. P7 it's nothing but this one, it's nothing but here. This is X7, this is P7. So all these values we picked from the table and we put it. Now 10k square plus 9k equal to 1. Yeah, we can see it now. 10k square plus 9k equal to 1. That is totally we added. How many k square are there? So 10k square plus 9k equal to 1. We will simplify. This is k square, a quadratic form we got it. So we are simplifying. Compulsory we will be getting the k value, 2 values we will be getting. We should get it because it is quadratic. The degree is 2. K value, 2 values we have to get it. So now we can see it. The k, how to solve this quadratic form. We know it, we studied in the lower classes, that is the factorization concept. Using that concept, this 9k, it should be splitted in such a way, plus 10k minus k, it's nothing but plus 9k. In these two, which is common, 10k is common, it has taken out. The balance we put it here, k plus 1. In these two terms, minus 1 is common. It has taken out. The balance we put it. So 10k minus 1, the common, it is k plus 1, k plus 1. Compulsory while doing the bracket, we will be getting a common term. If we are getting only, we are doing in a correct way of factorization. If we are not getting, then we did somewhere wrong. So the bracket common one time we are writing. Yes. Now this 10k minus 1 which is equal to 0, k value we got it 1 by 10. The next one, k plus 1 equal to 0, k value we are getting minus 1. So k, 2 values we should get it, we got it. But the 2 values, we are going to neglect this minus 1. The reason behind is, we know it, the k, it's playing the role in the regarding probability of x0, probability of x1, so on. So it is playing a role in probability. But we know it, the probability value always positive. That is the reason we are going to neglect this k value equal to minus 1. We are going to consider only k equal to 1 by 10 only. Yeah, we can see this is the reason. The reason is probability always is positive, and that is the reason we neglected this minus 1. Now we are declared k equal to 1 by 10. Out of 5 questions it is asked in this problem, we completed the first one. So now the second one, what it is asked, we can solve it now. The second one, it's nothing but mean they are telling us to find. Mean. This is the mean formula. This is the mean formula. That is summation I equal to 1 to n pixi. It's nothing but this mu, it's a symbol of mean. Otherwise, we can expectation of x. Anyway, we can tell. Now, according to our problem, it is 0 to 7. 0 to 7. So, we can write it I equal to 0 to 7. So, we can write it here. I equal to 0 to 7 pixi. So, I is taking the value first 0. It has taken. Next, I is taking the value 1. That is the reason P1 X1. I is taking the value 0 means in the place of I we are substituting. That is the meaning. So, I place we substituted 0. Here we substituted 1. Here substituted 2. Up to where we have to substitute? Up to 7 we substituted because our table up to 7. Now, we will apply the values in the particular places. Now, this is x0, this is p0. So, the value we can see it. So, we applied it 0 into 0. Next, in this particular place, we applied it k into 1 because this is x1, this is p1, k into 1. The next one, p2, x2. It's nothing but 2k into 2. So, we can see it p2, x2. The last one we can see it. This is x7, this is p7. All this we are multiplying. After multiplying, we are finding how many k squares are there, how many k's are there. Then adding, we got it 30k is there and 66 k squares are there. So, we got it 30 into 1 by 10. How it is this 1 by 10? Just now the first question, determine the value of k. We found the value, we got it 1 by 10. The k value, it is substituted in the particular place. Next is 66 k square. So 1 by 10 the whole square. It's nothing but 1 by 100. 1 by 100 into 66, it's nothing but 66 by 100. So we can see it, which is equal to simplifying 3 plus 0.66. 0.66. We got the mean value 3.66. So the next 2 questions we solved it. The third one we will go. The third question, it's nothing but variance. The variance formula is sigma square expectation of x square minus mu square. It's nothing. So very easily we can write it. Summation I equal to 0 to 7 pi x square minus mu square. Mu, now only we got the value 3.66 we got it. The particular place we have to substitute. First, using this summation notation, we will expand it. That is, I is taking the value first, initially 0. It has taken. Next, 1 it has taken. Similarly, up to 7 it will be taking. We will substitute the particular places, the values, looking at the table. We will pick the values from the table. Correctly, we have to pick. So, this is x0. This is p0. x0 squared. You have to be very careful. 0 into anything, 0. Next, p1 x1 square. x1 is 1. So 1 square is nothing but 1 and P1 is K. The next is P2 x2 square. X2 is 2. 2 square it's nothing but 4. So next P2 is 2K. The last we can see it. That is, this is x7. x7 square is 49. P7 is, it is 7K square plus K. Similarly, all the values we filled it. Minus, this is mu. Just now we got the value 3.66. The square is there in the formula. So that is the reason here we also put it the square. So mu square, it's the value is 3.66 the whole square. We have to do the simplification and we will count how many K squares are there, how many K are there. 124 Ks are there and 440 K squares are there. Minus this, it is written as it is. Now, K place the particular value. This problem we determined the value of K is 1 by 10. So we will substitute in the particular the K place the value 1 by 10. Here K square 1 by 100 minus, we can use a calculator. So 3.66 the whole square is, this is the value. Simplifications we have to do it. This simplifying we got it 12.4 and this simplification we got it 4.4. Minus is written as it is and this value also written as it is. So the final answer, the variance of this particular problem is 3.4044. So 3 problems away, divisions of this particular problem we completed. The fourth one, it's nothing, P of x less than 6. How to read this one? That is the probability of x, that is a random variable, when it is a less than 6. What is the probability? That is the question. This is the question meaning. Now, x is less than 6. That meaning is 6 is not included. We can see the notation. It is less than notation is there. Then it is strictly 6 is not included. When it is 6 is not included, less than 6, we will look at our problem. This is our problem table. Less than 6, what are the datas are there? So this is the data, it is there. 0, 1, 2, 3, 4, 5. So when x equal to 0, x equal to 1, 2, 3, 4, 5. Less than 6, satisfying, these are the datas according to our problem table we have taken. Now the same procedure, when x equal to 0, what is the probability? So it is not P of x equal to 0, it's nothing but P naught. P of x equal to 1 means it's nothing but P1. So now P naught, it's nothing but 0. This is nothing but P1. K, it is written. Next, this is P2. It is 2K. Next, this is P3. 2K. Now, this is P4. 3K. The last one, P5. It is K square. How many we can add? 8K plus K square. Now, we will apply the K value. It's 8 by 10 plus K square, it's 1 by 100. Simplifying, we got the probability of x less than 6. It's the value is 0.81. So the next, x is less than 6 we completed. The next one is x is greater than or equal to 6. We can see here the notation equal sign is there. The meaning is 6 is included. 6 is included and Greater than 6, what are the data? It is there. 7 is there. So these two are included. So that is the reason P of x equal to 6 plus P of x equal to 7. The particular thing, this is 2k square. For this, the probability is 7k square plus k. We will add, it's a 9k square plus k. The particular k place, we will substitute the value k according to our problem we determined. We found the value of k is 1 by 10. So k square is 1 by 100. So 9 by 100, it's this particular part value. K is 1 by 10. Simplifying using the calculator or manually, we got the value 0.19. So the next one is 2. X is less than 6 we completed. X is greater than or equal to 6 we completed. The next one is x less than 0 to 5. 0 to 5. Here there is no equal symbol. It is not given. That means this 0, it is not included. And here also there is no equal sign. So 5 is also not included. 0 and 5, they are not included. Between 0 and 5, the values to be taken. So between means 1 to 4. These data only we have to consider. So we considered. Now we will write at x equal to 1. What is the probability? It's k. At x equal to 2, 2k. At x equal to 3, 2k. At x equal to 4, 3k. So it is written here. Now we will add totally 8 k's are there. That is, we have to add this. We are getting 8k. Same, the k value we have to substitute. So probability of x lies between 0 to 5. We got the value 0.8. So next we have to do it. Probability of we completed x lies between 0 to 5. Now we will do x lies between 0 to 4. Now here we are able to notice it. Equal sign is there. It indicates 0 is included and this 4 also included. So 0 and 4 also included. From 0 to 4, we have to find the data including. We have to consider that 0 and 4 because of this equal sign. So 0 to 4. These data are we have to consider. So it is P0, it's 0, P1 k, next P2 x 2k, P3 2k, P4 3k. All the k's we should add. 8k. So we substituted in the k place, that is 8 into k value is 1 by 10. So 8 by 10 equal to 0.8. So the 4 problems we completed. The last one it is there. That is the 5th division. If probability of x less than or equal to k, which is greater than 1 by 2, that is 0.5. Find actually maximum value of k. Now we have taken first p of x less than or equal to 1. Suddenly we are taking x is less than or equal to 1, but in the table the value is starting from 0 onwards. Why we are not taking less than or equal to 0? That is a genuine doubt it will ring in our mind. So we can see it now. P of suppose x less than or equal to 0. If you are taking, there is no data, only it is there. That is also one of the reason behind this. We are not considering x is less than or equal to 0. So we are starting from 1 onwards. X equal to 0. So less than or equal to 1. Yeah, first we are going to take x is less than or equal to 1. equal sign is there. That is the reason 1 is included, and a less than 1 means 0 also included. So it is written P of x equal to 0 plus P of x equal to 1. So P naught P1. The values picked from the table 0 plus k. K value we substituted, we got it 0.1. Next, P of x less than or equal to 2 we are doing. 2 is included. Now for this is the data it is considered. So P naught, P1, P2. We will pick from the table. We got it 3k. It's nothing but 0.3. To solve this, the fifth division, first we are taking x is less than or equal to 1. Next, x is less than or equal to 2. Again, we are going to do x is less than or equal to 3. The reason why we are doing the before problems and all, the picture is very clear. X is greater than or equal to 6. The x lies between 0 to 5 and x lies between 0 to 4. The data are very clear picture and we did. But here it is less than or equal to k. The k only we have to find. So we ourselves we are thinking 1 it will be. So we got this value. And we are thinking maybe k will be 2. And we got this 0.3. Still we are not getting satisfaction. The word satisfaction, why we are not getting satisfaction? Then to do the satisfaction, what we have to do it? Now we will see it. So now, x is less than or equal to 3 we are doing. So 3 is included, this data to be covered. So we covered it, P naught, P1, P2, P3. We got it 5k and we got the value 0.5. We are not stopping. Again we are continuing. X is less than or equal to 4. So now for this, 4 is included. The data is this one, P naught, P1, P2, P3, P4. 8k we got it, 0.8. We are going to stop the procedure. The reason why we are stopping now, why not the before step itself? So the reason is, so we can see the reason why we stopped up to x less than or equal to 4. Why we are not moving to 5, 6, 7. So you can notice here when we are taking x is less than or equal to 1, we got the value 0.1. When x is less than or equal to 2, we got the value 0.3. If it is 3, we got the value 0.5. When it is 4, we got it 0.8. Again, we can do 5 is there, 6 is there, 7 is there. But we are not doing more further. The reason is the question P of x less than or equal to k greater than 1 by 2. So now when x is less than or equal to 1, this particular place, what is the value we got it? 0.1. 0.1 should be greater than, according to our problem condition, 0.5. It is mathematically wrong. 0.1 is greater than 0.5. It is mathematically wrong. Then, so we failure. The result we got it is not satisfying our given problem condition. That is the reason we are moving to 2. So when here we are keeping when x is less than or equal to 2, we got the value 0.3. It is greater than our condition 0.5. This is also mathematically wrong. Next we are moving to 3. So when x is less than or equal to 3, we got the value 0.5. It's greater than 0.5. This is 0.5 greater than 0.5. It is our problem condition. 0.5 is greater than 0.5. Mathematically wrong. Next, that is the reason The satisfying our given problem condition solution we are not getting. So we are continuing the procedure. 4 we are trying. So when x is less than or equal to 4, we got the value 0.8. So it is mathematically correct. The value 0.8 is greater than 0.5. So it satisfies when kx is less than or equal to 4 is greater than 5. Here we got it 0.8. One more doubt, it may ring in our mind. So 4 we have taken 0.8. If we try 5 also here, definitely more value only we will be getting. 5, 6, 7. Definitely 5, 6, 7 trying also more than 0.5 only we will be getting. Then why we have to stop at 4? The reason is the first, what is the solution we are getting to satisfy our problem condition, we can stop. We no need to proceed further. So we can see it now. So p of x less than or equal to 4, we got it 0.5. So value is 0.8. So the maximum, the value of k is 4. Conclusion. So the first actually today's lecture, random variable, that is what is the meaning of random variable, we did. So now the sample space, suppose the meaning of the random variable is one coin if it is there, head and tail, the output, the total output, or we can tell they are sample points, the total sample points in the sample space. It should satisfy the given condition. The given condition, suppose head we want it, then head is we are getting, that is probability of success. We are not getting head, no head, that mathematically the real number is 0. These real numbers are naming x1, x2. Then we are finding probability of x1, it's nothing but 0.5. Probability of x2, it's 0.5, satisfying the basic definition of probability. This everything it is possible because of the random variable. This is the random variable which the problem condition, what it is there, that is x from S to R. It is a real valued function because the results are given in real numbers, and that probability we are finding. And we are doing today, we concentrated on discrete probability distribution, that is discrete probability distribution, 2 conditions. The probability compulsory should be positive. Yes, it is positive. If we add, the total probability should be 1. If these 2 conditions are satisfied, we can see it. Yes, it is greater than or equal to 0. Here we can see the example. And compulsory, the summation should be equal to 1. Yeah, we can see 0.5 plus 0.5, which is equal to 1. So discrete probability distribution or probability mass function, that we concentrated. And we did one problem. So that problem we did 5 divisions. The small divisions we did, determine the value of k. This k value we found using the total probability distribution formula, and mean, variance, and small problems. X is lies between 0 to 5, x is greater than or equal to 6, and finally the maximum value of k. Everything today we discussed it. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.